All right, last time we ended talking about coordinate proofs, which are using our slope, midpoint, and distance formulas to prove all of these properties that we know are true about parallelograms. And so you're going to see those in action. We're actually going to do examples with those. So just a reminder, if you want to know about parallel, you're going to use slope formula because same slopes mean that they're parallel. Parallel lines have the same slope. If you want to know about congruent, we want distance formula for that. And if you're going to want to know about bisectors, that's what a midpoint formula can tell you. So you'll see each of those formulas happening. We're going to take the same parallelogram and we're going to do each of those formulas for that parallelogram. And on each one, I'm going to do one, and then I'm going to pause and let you try one, and then I'll show you the answer here. So first off, using both pair of opposite sides being parallel, that means we're going to use our slope formula, change in y over change in x. So I'm going to start by getting my slope for A to B. And my goal, don't forget, is that I want to compare that to the slope of the side that's opposite A to B. And my side that's opposite A to B is going to be C to D. So I'm checking A to B and C to D, checking those slopes and making sure that they're the same. That's my goal. So change in y over change in x. I'm going to take my y coordinates and subtract them. My y coordinates here are 5 and 3, and I'm going to subtract them over change in x. So my x coordinates are 2 and -3, and I'm going to subtract those. So when I take those and subtract them, 5 minus 3 is 2. 2 minus a -3 is 5, and I get 2/5 for my slope for A to B. So now I'm going to do my slope of C to D, and my hope is that I also get 2/5 again. And this one's easy because one of the points is 0, 0. So change in y, my y coordinates are 2 and 0. I'm going to subtract them. Over change in x, my x coordinates are 5 and 0. I'm going to subtract them. And when I do that, 2 minus 0 is 2, 5 minus 0 is 5. And there we have our slope of 2/5. So because these slopes are the same, I know that A to B and C to D have to be parallel to each other because they had the same slope. So now I'm going to pause for a few seconds and let you try the other pair of sides and prove that they have the same slope. So pause now and try that. And here comes your answer. Hopefully you got them both being -1, -3 over 3. Which means that B to C and A to D have to be parallel because they have the same slope. And since I had both pairs of opposite sides being parallel, that means that my shape is a parallelogram. So that's our first method, using the fact that parallel lines have the same slope to get my definition of a parallelogram. Now I'm going to use distance formula. And I'm going to use distance formula to prove my next property, which is that both pairs of opposite sides are congruent. And so since I know that two things with the same distance are congruent, I'm going to compare my opposite sides. So once again, I'm going to compare A to B with C to D. And this time I'm comparing my distance formula. So this one's a little bit more complicated. We have take the x coordinates and subtract them. So my x coordinates here are 2 and -3. I'm going to subtract them. Squared plus take the y coordinates. The y coordinates for A to B are 5 and 3, I'm going to subtract them, squared. Which gives me 2 minus a negative 3 is going to be 2 plus 3, so that's 5. So I take 5 squared, that's 25. Over on the y coordinates, plus, I have 5 minus 3 is 2, squared is going to be 4. And so my distance should be square root of 29. And remember, I want these sides to be congruent. That means that my distance from C to D should also be square root of 29. So let's take a look. We'll go quicker this time. For C to D, we have, subtract our x-coordinates. Our x-coordinates are 5 and 0 squared, plus subtract the y-coordinates. The y-coordinates are 2 and 0. Subtract them, squared. And that'll give me 5 minus 0 is 5, squared is 25. And then 2 minus 0 is 2, squared is 4. And lo and behold, 25 plus 4 is 29, which means that those two sides are congruent since they have the same distance. So once again, I'll pause here and let you try the other pair of distances and see if you get the same distances on both of those. And answer is on its way. You should get square root of 18, or 3 square root of 2 if you're simplifying your square roots. Either way, both of those have the same distance, which means that my pairs of opposite sides are congruent. Which gives me both pairs of opposite sides being congruent means that we have a parallelogram. Now, I won't show this next one in detail, but technically you could mix and match these, because remember that one of our properties was that one pair of opposite sides was congruent and parallel. The reason I won't show this in detail is because we already had our formulas. So one pair of opposite sides being congruent and parallel, which means we would use our slope formula and our distance formula to show that. So here's your slope formulas. There's that pair of sides being parallel. And then we're going to take that same pair of sides and do the distance formulas. Again, we already did these formulas. But we could take those same formulas and say, okay, that meant that that pair of opposite sides is also congruent. Since that same pair of opposite sides is congruent and parallel, we have a parallelogram. So that was a method that we could use to show that we have a parallelogram. So last method let's take a look at, which is that the diagonals bisect each other. And I know that because I'm looking for a bisector, I want to use the midpoint formula to do this. So I'm going to start with the midpoint of my first diagonal. Remember, my diagonal goes from one corner of the shape out to the other. So I start at A. The corner opposite it would be C. So that's my first diagonal, and I'm going to look for the midpoint of A to C. That's going to equal, take the x coordinates, add and divide by 2. Take the y coordinates, add and divide by 2. So first off, x coordinates, add and divide by 2. My x coordinates here are -3 and 5. I'm going to add and divide by 2. The y coordinates here are 3 and 2. I'm going to add and divide by 2. So if I work that out, I get -3 plus 5 is 2 over 2. And then 3 plus 2 is 5 over 2. Which 2 over 2 is 1. So I get the midpoint being at 1/5. So again, I'm going to pause and let you find the midpoint of the other diagonal. The other diagonal starts at B and goes down to D. And your goal is that the midpoint should come out to be the same thing in both diagonals, so that we have both of them being bisected in the same place. So pausing for a few seconds. And lo and behold, we get the midpoint at 1/5. Since those have the same midpoint, that makes them both be bisected in the same place. So at 1/5, both of them have that midpoint happening, which means these are the same, and there's our diagonals bisecting each other. So those are how the coordinate proofs work. Again, if you want to know about parallel, you're going to use your slope formula. Same slope means that they're parallel. If you want to know about congruent, you're going to use your distance formula. And then if you want to know about bisecting, then you're going to use your midpoint formula.